Thank you to Mobilization for having me here. It's been a great conference for me so far. I hope you all enjoyed it as well. And thank you for sticking around till the 5 till 6 p.m.-ish slot. I know it's not normally the most popular slot of the day, but good to see you all here. So briefly, a little bit about me. That's my giant face. That's what I look like on the internet. A little bit more hair up top and a little bit less on the face. I currently work for a company called Detroit Labs, based in Detroit, Michigan. We're a consulting company, and we work with clients to help them build great mobile apps and great teams. You can reach out to me on Twitter at skentphd, and that'll be on the slides throughout the talk if you want to tweet anything at me. So why am I giving this talk? So at the beginning of 2017, one of the clients I was working with asked us to build a smart speaker application. So this is an application that allows you to connect to and control smart speakers. And it was a really fun application to build, but it was also a really frustrating technology stack to work with, specifically on Android. And there's a lot of information out there about how to use this on Android, but a lot of it is also scattered around the web. And so what I wanted to do is put it all in one place so that if you're someone who wants to build a BLE app on Android, this is the place you can come, and you can feel reasonably assured that you're going to be told all of the things that you really need to know ahead of time. So I'm not going to assume anything about BLE knowledge in this room. Let's do a quick survey. How many of you are developers? Okay, vast majority. How many of you are Android developers? Again, vast majority. And how many of you have worked with BLE on Android before? Okay, some. Okay, that's more than most audiences for this talk. So I'm going to do a quick BLE basics recap, just so we're all on the same page with that. Then I'll talk very briefly about the Android landscape, what's already out there for building Android applications with BLE. And then we'll basically run through an implementation, starting from scratch and going through all of the stages that you would normally go through to build a BLE application. I'll show you the code you're going to need to write in particularly tricky spots. I'll show you the things that are particularly non-obvious. And by the end of it, you would be able to walk away and use this as a fairly complete guide to building your own application. So let's start with some basics. So what is Bluetooth Low Energy really good for? It's good for small amounts of data, and it's intended to be quite easy to use, mostly from a user perspective. So it's meant to be easy for communication to happen here, and it's meant to be easy to do that sort of initial connection. The range is up to about 100 meters, and BLE, the clue in the name, Bluetooth Low Energy, is that it was designed also to allow relatively low power usage. So you'll often see it being used in small peripherals that are deployed where they run on like a cell battery for a number of years. You don't have to build low power usage applications with this, but that's one of the things that it enables. So if you are a BLE device, you can be in basically one of two roles. And the first role is a central role, and the central normally behaves like a client. Now, when I say client and later on server on this slide, the analogy you should be thinking of is like your web client and web server. That's a good analogy to have in this case. So the central normally acts like a client, and that means it will consume data from the server, and it will also sort of send instructions to the server. The peripheral is the other half of this equation, and that normally acts like the server, and that will expose data that clients can then consume, and it will also be listening for commands and responds to those commands. So just a few examples of devices that we would probably be familiar with in those roles. So if any of you used a heart rate monitor that uses BLE, that's going to be the peripheral in this scenario, and it's going to be acting like a server, and therefore it's exposing heart rate data that your phone is going to consume. So your phone is playing the central role here. And the phone could, aggregate this data over time or show you a pretty graph, do something with this server data in much the same way that your web client would consume web server data. On the other hand, if any of you have played with those fun smart bulbs that let you change the color of your room, again, the smart bulb is kind of playing the peripheral role here, and the phone is playing the central role, but this is more based on sort of commands being sent from the client, from the central to the server. So you might say, make this bulb show red or make it show green. So the relationship is the same, but the way we're using it is slightly different. And then you can obviously get much more complicated scenarios. So this is what the application that we built looked like, where we had connections to up to 6 peripherals at the same time. These were all smart speakers, and we would sometimes want to know data about what the speaker's current state was, and we would also want to be able to send commands to the speaker to do things like change volume or change preset, things like that. So one of the things you need to know when you're writing this is what the server profile is going to look like. So again, think back to that web server analogy where if you're building a client for a web server, somewhere along the way you're going to need documentation that says these are the endpoints, this is the data you can expect from each endpoint, this is what's available to you, basically, as a consumer. So server profiles play that role for us in Bluetooth Low Energy, and the basic unit of these profiles is a characteristic. So think of a characteristic as kind of like an individual endpoint. Each characteristic will have a value that can change over time, and it will also have descriptors, which are basically metadata for that value. Characteristics are then grouped into services, and then this collection of all the services represents the entire profile. And everything in this profile can be referenced by you using a 128-bit UUID, basically a long string. So for the visual learners among us, that's kind of the same thing that I just said, but displayed visually. And again, sort of the pinkish characteristics are sort of the fundamental unit that you'll need to interact with, but you need to know all this profile information to be able to set up BLE communication in the first place. You'll also encounter two main types of server profile. So I'm calling these standard and then custom. So a standard profile is one where all of the services that are offered and all of the characteristics that are offered have been predefined by the Bluetooth special interest group, and they're like the standards body for Bluetooth. And in that case, you would really want to be doing something like this where you're building an application that you want to be able to interop very well with peripherals from different manufacturers. So if we think back to that earlier example of a heart rate monitor, if I'm building an application that I want to work with a heart rate monitor, I probably want it to work with a heart rate monitor built by any manufacturer. I probably don't want it to lock it down to one specific implementation. And that's where this kind of profile would come in. Whoever built the heart rate monitor would conform to this profile, and then you could just look for any device which advertises it. And you don't need to know, essentially, you don't need to know the implementation detail of that heart rate monitor. You can be assured if it advertises this profile that it will have a heart rate measurement characteristic and a body sensor location characteristic. So you can also see there's a couple of other things that we need to know that are expressed here in this profile. One of those is what we can actually do with these characteristics. So we can subscribe, essentially, to updates from the heart rate measurement characteristic, and that's like receiving push notifications from your server, essentially. And then we can also read where on the body the sensor is located, whether it's on your wrist or around your chest. And then there's type information as well, which tells us what type to expect this data to be formatted in. So you'll often see, if you read about standard profiles on the web, you'll see the four values that are highlighted in yellow there. You'll see these sort of 16-bit UUIDs used to reference each of these components. And that's because for these standard profiles, it's kind of like a shorthand. They take these 16-bit UUIDs and stick them into this 128-bit template. So if you look at all of the other characters displayed here that are not highlighted yellow, those correspond to the standard template for a standardized profile. So the alternate to this is a custom profile, and this would be something that you use when you're building a fully custom peripheral, where you don't expect interoperability to be a thing that you're going to be concerned about. So this is what we did for our smart speaker app, because we were working with the hardware team. We knew exactly what capabilities we wanted to build into this application. We could ask them to make changes to the profile. In this case, you can choose whatever UUIDs you want, because you're not going to follow any standard specification, and so if you don't really care about anyone else being able to write an application for this custom hardware. So let's talk a little bit about the Android landscape right now as it pertains to Bluetooth Low Energy. So there are a bunch of abstractions already available to us. I'll run through them pretty quickly. SweetBlue is a very full-featured abstraction, but it's a proprietary library, so you have to license and pay for it if you want to use it. RX Android BLE is a popular option, but because of the way it's built as a reactive library, it doesn't actually allow you to hold a persistent connection to between a central and a peripheral, which was problematic for us. It may not be problematic for you, but it was for us. Android Bluetooth library is something that I've seen but not really explored yet. And then, sort of as a crazy left field option, the nearby APIs are built partially on top of Bluetooth, and they obviously offer a very specialized feature set, but if that's a feature set that matches exactly what you're going to do, you may as well use that abstraction and leverage it rather than building something custom. None of these really suited what we were going to do, and so what we did was build from scratch. That may be the case for you as well. I also always like to build from scratch kind of the first time so that I get into all the APIs and learn them, and then I feel a bit more comfortable sort of evaluating other abstractions. So let's go down this build from scratch route and talk about the landmarks that we're going to see along the way on this journey. And I'm going to make a few assumptions just to make my life a little bit easier, And I also recommend choosing these assumptions to make your own lives easier if you ever build BLE stuff on Android. So we're going to be talking about code from the central role. Again, if you think back to that diagram of the phone and the speakers, the phone was the central, so that's where we wrote code. It's perfectly possible for your phone to act as a peripheral. In this case, I'm, for simplicity, just going to look at the central role. I'm also going to stick to Lollipop Plus. BLE exists back to Jelly Bean, but it's a little finicky on pre-Lollipop. So if you can, I recommend going with Lollipop Plus. For us in North America, North American apps that we have in already released to the Play Store, we're looking at Lollipop at about 97% plus, so it's not really too much of a user base loss for us to do that. I'm also going to talk about BLE only. A lot of implementations that you'll see will have BLE versions and then they'll fall back to Bluetooth Classic if the device doesn't support it. Again, if you're on 21 plus, that's not so much of an issue and you save yourself a lot of headaches not having to do that, write everything twice essentially. And I'm not going to talk about the pairing process, which is, I'm sure all of you have experienced, where you pair your car with your phone or something, where you type in the digits. That's not something we had to build for this application. I don't know much about it. That's something you'll have to learn on your own, I'm afraid. Sorry. So these are the stages that you sort of go through on this journey of building an application. And I'll talk about each of them in turn. So the first one is planning and then preparing your application. Then the next thing you'll do is sort of scan for these peripheral devices to see what's around you. If you find one, then you can connect to it. And once you've connected, you can then interact with it, and that's where all the fun stuff happens. And then at the end, you definitely need to disconnect. So what goes into the planning phase? So you would think this might be pretty straightforward, but this is one of the things that took us the longest to figure out when we were building this application. So when you have a central, you can have at most 7 peripherals connected. So that's something to bear in mind when you're designing an application. If you think you're going to need hundreds of these things connected to a central, that could be a problem. Even more tricky is that when I talked earlier about those sort of push notifications, the subscriptions that you can have to values on a server, you can have at most 15 of those per peripheral. And that is an Android-only limitation. So that is not a limitation of the Bluetooth Low Energy stack. It is not a limitation that you will see on iOS. That is a limitation of Android only. For a while, we thought this was going to be 15 subscriptions per phone, so that you would have to sort of manually poll your peripherals if you ran out of notifications. 15 turned out to be just enough for us for these speakers. I think we ended up with 12 subscriptions going on simultaneously. But this is a really good thing to know up front before you make promises to product owners. If you're going to have a lot of subscriptions going on, bear in mind this 15 subscription limit. And then also, it's good to think about ahead of time, is this app going to be something that works even if BLE is not available to you? Or is it something where BLE is really core and it doesn't make sense to have this application be available if there is no BLE? It will affect some of the distribution stuff that we choose to do in a few slides' time. Okay, so we've planned our application and we know what we're aiming to do. The next thing we should do is probably prepare, and what I mean by that is, first of all, check that we have the capability to support BLE on a phone. So one of the things that we'll need to do in our manifest is declare the permissions that we require. So Bluetooth and Bluetooth admin. Bluetooth admin might sound scary. It might sound like maybe I shouldn't take this until I need it, but it's effectively essential. You can't perform scanning without the Bluetooth admin permission. And if you can't scan, you can't do anything else, so you have to ask for it. Luckily, both of these are normal level, not dangerous level permissions, and so you'll be automatically granted both of these freely. Something else I also recommend, and this harks back to that question about whether BLE is going to be required or not, you can use the uses features tag in your manifest to declare that BLE support is required for this application or is preferred for this application. So for us, it didn't really make sense for this, the whole concept of this app was built around BLE. It didn't make any sense for there not to be BLE for a device. So by specifying this in the manifest, what will happen is if someone on a device that doesn't support BLE is browsing the Play Store, your application will just not be visible to them. So they won't be able to install it from the Play Store. However, I would still recommend building in some runtime checks in your applications. First of all, for your own sanity, because you won't be able to deploy it on the emulator if you, well, you'll be able to install it on the emulator, but then it will crash because the emulator doesn't support Bluetooth. And secondly, there might always be users who are sideloading applications not through the Play Store. So this is the right way to do a runtime check of Bluetooth and Bluetooth Low Energy support. So the next thing is, once we've established that we have actual support for BLE, we probably want to know what the state of the BLE stack is on the device. So you can query this at any time using isLE enabled. And you can also register for broadcasts and receive notifications that way when the Bluetooth state changes. The correct action to use there is Bluetooth adapter action state changed. So when you receive those actions, or when you explicitly check, you should treat anything that's state on or state BLE on as BLE is ready to go for you, and treat everything else as off. There are some weird states that can come through in there. Just wait until you have an explicit on before doing anything else. If you detect that Bluetooth is not on and you would really like it to be on, you can use this Bluetooth adapter action request enable to fire an intent that automatically handles a really nice re-enabling flow for you from within your app. You don't even have to send the user out to settings. You can just prompt them right there. That's a really nice convenience offered to us by Google. And then if BLE being disabled really prevents users from using your application in a meaningful way, always have the option of throwing up a blocking activity to say, hey, you cannot go any further without enabling this. Please do so. So assuming that we know BLE is switched on and it's ready to go, the next thing we want to do is scan from our central to find these peripherals that are out there, if they're out there, and then do something with those results. So you can get the scanner from the Bluetooth adapter by first of all getting the default adapter and then calling get Bluetooth LE scanner. So a warning here, that get default adapter call will return null if Bluetooth is not supported. Hopefully that's something we've already taken care of with those manifest entries and runtime checks. But get Bluetooth LE scanner returns null when Bluetooth is disabled and returns non-null when it is enabled. So that's dynamic rather than the static non-null null of the default adapter. So basically what this means is you should make sure you check your Bluetooth state very aggressively before doing anything with the scanner. Because if you checked 5 seconds ago that Bluetooth was on, and then you get the scanner, and then you reuse the scanner, or then you re-retrieve the scanner, but Bluetooth has since been turned off, you'll see a crash, a null pointer exception in the application. So just be careful with that. So this is how we actually start scanning. We take that scanner and we call start scan. And there are 3 parameters here, and I'm not going to say too much about filters and settings, but they basically do exactly what you would expect. Filters out the results that you're interested in, and settings sort of specifies whether you want a high power or low power scan. The most interesting thing here is the scan callback, and that's what's going to process all of the results that we get from our scanning. So that's what it looks like. It has a single method on scan result, and we will be fed scan results one at a time through this method. So right now, if we do this, what's going to happen is you're not going to get any results at this stage, and the failure is going to be quite quiet. It's not going to be a very loud crash or anything. You're just not going to see any results in this thing ever. So that's what this quiet failure looks like. It's a warning level log statement in your logcat, so not super obvious, but it's warning us that we actually need course location or find location permissions in order to receive scan results. If you've not worked with BLE on Android before, you're probably a little confused about this. The reason is that you can actually infer user location from the result that you get from a Bluetooth scan, and so this is Google kind of being very cautious about saying, we know you could potentially figure out location here, and so we're going to make sure that you tell the user that's a thing, even if you don't use the information about location. So this speaker app that we built has no interest in where you're located, but we still have to ask for this permission, and so will you if you're using BLE. So I recommend asking for the course location rather than the find location, because why not? It doesn't make any difference. And again, up to you. If this is something that's really required for your application, you can use that same users feature manifest entry to say, don't bother showing this to people who don't have the capability to detect location, because they'll never receive any scan results anyway. And then, since most of us are Android developers, I'm going to skim this pretty quickly as well. But you have to do the whole song and dance now with requesting permissions, waiting for the the response to the permission request, and then retrying your scan when you know that you have permission granted. So I can guarantee you that this need to ask for location is going to confuse your users. It confused our product owner many times, even though we'd previously explained it. So the steps that we took to mitigate this were that we actually explained it, very upfront in the Play Store description. We didn't sort of try and hide it and say this is, this is not a thing. We said we are required to ask for this, and here's why. I recommend also always presenting like a custom explanation dialogue. So in the sort of the standard way of doing a permission ask is the first time you just ask blank, and then the second time this should show request permission rationale flag will be set, and that's Google telling you this has been previously denied. You might want to explain a bit more fully before making the permission ask. I recommend not even bothering with that. Just always explain, because it's always going to be very confusing that first time. And again, one of the options you have here is making sure you use a blocking activity if you really, really need to be able to receive scan results. So let's assume that we fixed that. The next thing that's going to happen is we're still not going to receive any results, but this time the failure is going to be absolutely silent. There's not going to be anything in your logcat either. And that's because an additional requirement is that your location services actually have to be switched on when you're doing the scanning. So not just the permission, they have to be actively turned on. This one I have no understanding of, just it's a thing. So the best way to check this is to call this settings secure method and treat your location as on anytime it doesn't say the location mode is off. Because you don't really, it doesn't matter which location source you're using, whether it's network or GPS, as long as there's one of them. So just check that it's not set to off. Again, you can prompt to enable with action location source settings to bump people out to location settings, or if you have Play Services in your application, Play Services has a nice location settings request that will allow you to re-enable location services from within your application. And again, I'm saying this a lot, but it bears repeating, use a blocking activity if not being able to receive scan results is really problematic for your application. So once we've done, jumped through all those hoops, we should now be actually getting scan results. Hooray. That took a little while. Once we've started scanning, note that we must actually stop it manually. So it will, when we start, it will just continue going until we say stop. So there's a couple of different strategies you can use here. You can stop whenever you receive the first result. You can scan for some fixed duration of time and then put all the results together and display them to the user for choosing between. And you should probably also make sure you are careful about stopping scanning when the app moves into the background in the middle of a scan. So just to show a couple of examples here, which one you'll prefer will depend on your use case. This is an example of just saying, as soon as I receive the first result, stop scanning right there after checking that my BLE scanner is not null, because remember, that could be null if the BLE has been turned off. And then just retrieve the device from this result and connect to it. The second option is if you want to scan for a fixed duration, what I recommend here is putting your results into a set. So you might receive the same result multiple times if you're scanning for 5 seconds, and you probably don't want to show the user 10 copies of the same speaker or same peripheral. So using a set will prevent you from showing multiple copies. And then I prefer using a sorted set so that I have some control over which order I'm going to display them to the user in. If you go with this route, in the on-scan result, you just add your new scan result to the set, and then at the end of however long, 5 seconds, you'll process them at that point. So that's what the processing looks like. As soon as you call start scan, just post a delayed runnable that's going to stop the scan and then do something with those scan results. So let's assume that we've got some scan results, maybe one, maybe more, and what we'd like to do now is connect to the things so that we can actually interact with them. So the way we do that is we take the device from the scan result and we call connect GAT. Again, 3 parameters here. The context is what you would expect. The second parameter, auto connect, I've never really understood exactly what it's supposed to do, but I've heard that setting it to true can result in very aggressive connection attempts. So I've preferred to set it to false and sort of manually manage that myself. The really interesting thing here is, again, the server callback. So that server parameter up top, we're going to keep a reference to that, and this server callback, that's basically going to be all of the stuff that we touch for the whole rest of this thing. We're going to call methods on the server to make things happen, and we're going to receive results in the server callback. So those 2 things are going to be really essential for basically the rest of this talk. The server callback is this giant Bluetooth GAT callback thing that, as I sort of explained, is going to tell us everything that happens on that remote peripheral device that we're talking to. So it will tell us when the connection state changes. It will tell us when we've correctly read a characteristic value or when we've written a characteristic value. There's a lot in here. I've sort of highlighted the key methods. There's some more esoteric stuff that I have never really had to touch. But yeah, this is a big thing, and this is going to be a large part of your implementation. So once we've called that connect call, what we're going to be looking for is a callback to on-connection state change, with the connected state being state connected. And at that point, we know we're good to go and actually interact with this device. So there's a preface that we need to get through before we can actually do any interaction, and that is command queuing. So any other interactions that we have with this device now must happen one at a time. And this is kind of confusing because of the fact that this whole API is designed with that sort of asynchronous nature, where you call a method and then receive a callback. And if you think back to that web server analogy, when you're using a web server, you're probably used to being able to fire off multiple calls at once and receive all those results whenever they come back and then aggregate them. You don't have to worry about sort of doing them one at a time. That would be kind of inefficient. But unfortunately, that's what we have to do here in the BLE APIs. So it would be incorrect to say, take my server and call command A, and then immediately take my server and call command B. What would happen in that case is that command A would be overwritten and would just never happen. So you'd never receive a callback for it. The correct way to do this is to call server.command A, and then wait for that callback to tell you that it's done, and then call command B. This is true across all connected devices. So if you're connected to 6 speakers, you have to make sure it's true across all of those 6 speakers. So now I'm looking at 2 servers, server 1 and server 2. I can't call server 1 command A and then server 2 command B. That will also overwrite server 1's command A. So again, even though I have 2 separate peripherals here, I have to say, do command A on server 1, wait for that to finish, and then do command B on server 2. It's a lot to manage and a very sort of confusing setup. So this is why when you are talking about BLE on various websites, you will see solutions that look a bit like this. You need delays for pretty much everything in BLE, so just take your thread and sleep it for 100 milliseconds. The problem with this is that it doesn't really get at what the core issue is, which is that you need to wait for that command to finish, and you don't know exactly how long that's going to take. So that's why you might say, for example, actually 500 milliseconds was how long I needed to wait. The problem is that this keeps escalating. So you might be okay if you add a 2-second delay always, but actually no, you probably still won't be okay with a 2-second delay, because these calls can take varying amounts of time. So the right solution here is to manage that one-at-a-time nature of these calls ourselves. And so the way we chose to do this was to build this on top of a queue. So I was kind of excited by this because I don't have a computer science background, and so this is the first time I got to work with a data structure that was more interesting than like a hash map. But a queue is a first-in, first-out structure where you can submit things to the queue and they'll be put on the end, and then the queue gets processed from the front. So what that looks like for us was making this abstract class which represents a command that we would like to execute, and we're going to put these commands into that queue and then sort of process them one at a time. So sorry for this is quite a text-heavy slide, but instead of calling those server methods directly, if you want to read a characteristic, say, what you would instead do is create an appropriate command and then submit that command to some kind of central manager. That manager is going to be the thing that wraps the queue and makes sure that the queue is only processing one element at a time. And the way it does that is by taking the next command from the queue, sending that command off to the appropriate peripheral or server, and then waiting for that server to tell it that it's done. Once the server says, I am now done, this command manager will take the next item from the queue, send that off to perhaps a different server, and then just keep doing this as long as the queue is not empty. So this sounds like it might be a little complex. It's not really. This is an entire simple implementation of that command manager. So it might be a little small to read, but I'll just step through. There are 2 fields here. One is the queue, and one is the currently executing command. And then there are 2 methods. One to say, hey, I would like this command to be executed, and one to say, the command that was currently running is now done. And the logic in the 2 of these methods is actually pretty similar. It's just the logic to say, if there's another item waiting, now start with that one. So not too scary, I hope. Just not too obvious either. So now we've got this queue mechanism in place, we can start to do those interactions, and the first interaction that we have to do is discovering the services available on this device. So this is necessary, I don't understand this either, but this is necessary even if you know the server profile. So remember the server profile told us which services were available and which characteristics were within those services. This is a step that we have to do programmatically, and we can't interact with any characteristics until we've done this. This is kind of a slow operation. It might take 1 to 3 seconds, and it must occur after connection and before anything else. So this is basically the next thing that we have to do in our sequence. So I'm going to go through this example of the command in a fair amount of detail, and then a lot of the ones that follow subsequently will be very similar structure, just slightly different, so I'll be a little bit quicker about those. So what we've done here is we've made a discover command which extends our base command, and this is going to be the thing that we submit to that command manager. And all it needs to know is the server ID so that we can dispatch it to the correct peripheral. And then there's sort of these 3 steps that will happen for all of these commands. So the first step is I am at a point where I want to discover the services. So this is probably happening just as you know you've connected. So instead of saying, instead of taking the server and calling discover services on it immediately, you'll say, make this discover command and then send it to the manager. If the manager says it's good to go right now, then it will come back to me immediately. If the manager says there are other things that need to happen first, I'll get it at some point later. So that's like the middle piece of this. Later on, we'll be told, hey, you can now perform that discover command that you were expecting to perform earlier. So that's when we'll actually call server.discover services. And the manager is assuring us that nothing else is going to be going on at the same time. And then later again, this discover services command will complete, so we'll get a callback to that server callback on services discovered method. In this, we'll want to save a reference to the service that we get back. That's how we're going to retrieve characteristics later on. And it's also super important that we tell the command manager, this command just completed, you can now proceed to the next one. So this sort of 3-step, submit a command, be told to execute the command, report that the command is completed. That's how everything else is going to go from now on. And by everything else, I mostly mean interacting with individual characteristics. So remember, these are like the endpoints where we have actual values that we might be interested in reading or writing. This might be like your heart rate, for example. So for a read, again, we make a read command which extends the base command. And in this case, we need to provide the server ID, but also provide the ID of the characteristic that we want to read. This will be that UUID that you can look up in your server profile. Somewhere. And then again, not to belabor the point, but the same 3 steps happen here. So instead of immediately reading, I would say, hey, command manager, please, I'm requesting this read characteristic command happen. Whenever it's appropriate for it to do so, the command manager will tell me, hey, now is a good time for you to execute that command. Go ahead and read the characteristic. And then later on, when the characteristic is read, I'll get the value back, and I can do something with whatever the value is. So I might have read the current temperature or my current heart rate. And then I must tell the command manager that that command completed so it can carry on. Writes are very similar, except that as well as the characteristic ID, we need to actually tell which value we would like to write to this characteristic. And this middle block gets slightly more complicated, but again, the same 3 parts of this structure. And again, you must report completion. And then notifications, this whole subscription-based mechanism, this is a little bit more confusing because you are required to do some remote configuration of a descriptor, as well as local configuration to your Android application. So I'm going to show you these slides, but I'm not going to expect you to remember them. Just know they're in the slide deck if you need to read them later. So the enable notifications command says which server and which characteristic do I want notifications for, and then there's a lot of text here, but it's basically the same thing. The only difference I'll point out is there are sort of 4 sections here instead of 3. The 3rd section is where the command actually completes. So that's the part where you say notifications are now enabled. You can proceed to the next next command, and then your actual results will be passed to a different callback on characteristic changed. So I'm just calling out there which one of those is the one you want to report the completion in. It's when you are told that the descriptor was actually written. One warning here, again, this one took me quite a long time to figure out. All of those server callback methods that we're looking at, they catch and then log any exception, like any exception. This can be a problem because, as I've tried to make a point of, it is very important that we always tell the command manager when our command is finished, because what will happen if we don't do that? It will think the command has never finished, and it will never do anything else. So if we ever fail to report that a command is finished, that stops all Bluetooth activity in the app forever. Well, until a fresh boot. So you must catch all exceptions yourself in these callbacks. And so I recommend that what you do is write all of your happy path code in a try, do whatever you want in the sad path, in the catching a generic exception, but then in a finally block, always do that report so that it never, never doesn't happen. Something else to know, and is really not fun, is that a lot of these commands, this read descriptor, write descriptor, a lot of them are just going to fail sometimes for no good reason. There won't be any informative error code. It will have worked the last 100 times, and it won't work this time. So my recommendation to you is assume the worst and code very defensively, even if you think, I've just discovered this service, there's no way the characteristic is going to be null when I try and look for it, but it will happen. My recommendation also is anytime you get a result from one of these commands that's not a success, tear down the entire connection and start again from the very beginning. Trying to recover midway is unlikely to be useful to you. But if you do that, make sure you timebox and limit the number of retries, because I have had issues with commands where retrying them, they would fail immediately. And so if you didn't limit the number of retries, you would basically lock down the app while it was spamming these retry requests indefinitely. So all the good stuff has happened now. We've interacted with our peripherals, and it's been super fun, and we've written some queues and stuff like that. At the very end of the day, what we want to do is make sure we disconnect cleanly from this peripheral. And the way we do this is by calling servo.disconnect. And once servo.disconnect has finished doing its thing, what we will do is receive a callback to onConnection state changed with state disconnected as the state. And at that point, you should call servo.close. Now, I don't really understand the difference between disconnect and close. Just know that both have to happen. So the unfortunate thing is that callback to onConnection state change, that might just never happen. I'm sure that if you are an Android developer and you've worked with activity lifecycle, you know how important it is that we have these beautifully matched pairs of lifecycle methods so that whatever I did in the onStart, I can stop in the onStop. It's really disconcerting when onConnection state change might never be called for you to do this teardown. So my recommendation here is whenever you call disconnect, post like a 1 second delayed runnable that will call close. If you receive the disconnect callback in the meantime, you can just discard that runnable and do the close yourself. And if it just doesn't appear, call close anyway. If you don't call close, that basically takes up one of your limit of 7 concurrent connections. So if this happens to you a lot, eventually you will run out of connections, and you won't be able to connect to any more peripherals until you reset the whole Bluetooth stack on the phone. One other thing to note is that you will unexpectedly get disconnected a lot from devices, even in perfect conditions. So, I'd be sitting with my phone developing with a speaker next to me on the floor, and periodically I would get a disconnection, maybe once every minute or two. So it's going to happen. Again, kind of like the operation errors, if that happens to you, just tear down the connection all the way and start from the connect call again at the beginning. It's a little slow and it's a little annoying, but the chance that you're going to recover properly from an unexpected disconnect in any other way is slim. One thing that we did is we had a Boolean in our application that would track whether or not this disconnect was deliberate. If it was deliberate, we would allow the disconnect to happen. If it was not something that the user had initiated, we would then go into it like an automatic reconnect try, kind of like I discussed before, where we would automatically try to reconnect up to 5 times or for up to 30 seconds. And again, important to timebox and limit the number of retries that you allow there. So this is basically the end of the journey in quote marks. This is a sort of a minimum viable BLE product that you have going on now. If you want to do something a little bit more advanced, there are some more slides sort of hiding at the end of this deck that I'm not going to talk about, but just know they're there. And these are some of the problems that were more specific to our application that you might or might not have to worry about. So one of those was service caching. This is an issue with the result of that discover services call. That result is cached because it's kind of expensive. And that's a problem if the hardware that you're using is evolving, like the services on it are changing as they get developed. So I have some code in here to show you how to clear that cache. It's a hidden method that you need to call. We also had some interesting issues with buffering. If you think about controlling a speaker, you normally have like a slider to control like volume up and down, and those sliders spit out events, like spit out values very, very quickly. But Bluetooth, over Bluetooth, it takes sort of 100 to 300 milliseconds for a round trip for one of those commands to be sent. So if we just sent every single event that was being triggered by that slider, we'd get the speaker sort of lagging seconds behind the actual control. So we did a little bit of finessing of the queue there to make sure that we minimize that lag. And then also, I haven't talked anything about what you want to do if you need a long-lived connection. Part of this speaker application was monitoring the health of the speaker during a performance. And so we needed the app to be able to keep that connection alive for extended periods of time. So there's some tips in there. And then lastly, I compiled this resources gist, which is basically a list of all of the things that I've referenced while building this app. So this is Stack Overflow Q&As, this is Google issues that I'm tracking, this is good videos, good introductory material. I would recommend going there if you're serious about building something on BLE for a really good overview of all of the things that you might need to know about. And that's what I have for you. Thanks again.
Hello, thanks for the talk. You mentioned on one of the slides that there is a limit of 7 connections per central. Yes,
yes.
Correct?
Yeah.
Where did that number came from?
So
is it in the docs?
I believe
perhaps?
that's a BLE limit. I believe, like a limit of the Bluetooth protocol, or Bluetooth Low Energy Protocol.
So Bluetooth, so not hardware but software. Yeah, you mean the Bluetooth stack?
Yes, it will be put into the Bluetooth stack, and I have heard that Samsung has occasionally raised that limit to 8 or 9. I would worry about if it went any higher. I would worry about disconnections and things becoming even more frequent. We definitely noticed that connection stability was better if we were looking at 1 or 2 speakers versus 5 or 6. I don't know if that's a stack implementation issue or part of the BLE protocol itself. I never really had to dive too deep into the BLE protocol, but yeah, that's I can at least tell you that that limit is the same on iOS and Android. So as a mobile developer, it's effectively written in stone.
Okay, thanks.
Yeah.
Hi. As far as I know, the limit is 7 for Android, but some producers like Samsung have even 15 for some devices.
Mm-hmm.
And my question is, how do you handle multiple connections to devices, to several peripherals? Do you use several GATT objects?
Yes, yes. So the server object that we had, you would have one of those per peripheral that you were talking to. Yeah. So we had a class which basically represented an individual speaker, and we would have some number of those, and all of them would submit to the same instance of the command manager. So that's the key thing, is making sure that no matter how many you have, all of the commands that you're performing go through a single command manager so that they are locked one at a time across all of those peripherals. But yeah, you would call a separate connect method and have callbacks on a per peripheral basis, yeah.
When I developed some app, I found that some errors are pretty hard to define what it is. It's
yes.
something like after connection, the error 130.
Yes, 129 and 133 will show up a lot.
Do you have some strategies to solve this?
Do I have some what, sorry?
Strategies to solve this?
No, the strategy is that tear down and reconnect. It is a... But I will say, I have seen it work in that I have seen a connection or a command fail with a 133, and then I try it immediately afterwards, and it works. I have also seen the opposite, where I retry it and it immediately fails like 5-6 times over. But yeah, I was not convinced until I saw it happen that it could happen. But yeah, you can try something and then immediately retry it and have it work. A little unfortunate, but that is the best recommendation I have, I'm afraid.
Yeah. Hi, Stuart. Thank you for the great talk. Actually, I have a question regarding multi-threading.
Okay.
Have you tried to launch those GAT callbacks from other thread than the main thread, and have you experienced any kind of an issues in such environments?
So my understanding is that those callbacks are not actually guaranteed to be called on the main thread. I don't know if you've read, there's a blog post series currently in progress by Eric Hellman where he talks a little bit about the threading around this. And the way he explains it is that in almost all Android APIs, those callbacks will be invoked on the main thread, but that for Bluetooth, they're actually invoked on the binder threads that underlie the implementation, which is sort of a horrific implementation leak, if you like. So his recommendation is sort of to push everything off onto a separate thread when you're doing work in those callbacks. We didn't find that to be too much of an issue because we weren't doing a lot of blocking work in those callbacks, so we weren't at risk of blocking binder threads. And therefore, just working with sort of our own managed queue was sufficient to avoid any issues with sort of interweaving of threading. That's the nice thing about that queue solution is it really, as long as you synchronize the request and report methods, that sort of takes care of everything for you. So yeah, it might be the case that a solution where you explicitly bump off to a separate thread is a little more stable, but in reality, I haven't seen it be a huge issue. Yeah.
Okay, sir, it was the last question because we are run out of time. I would like invite everyone to the final summary of the of mobilization, and I would like to remind you that there is an after party. So thank you, Stuart, for the speaking.